Hello, my name is Andrew Blake, and today I'm going to be talking about smart power grids and automation. So first, a quick overview of my presentation. I'm going to go over the motivation for why I chose this topic, go over an overview of the existing power grid, discuss generation methods, talk about the technologies used in a smart grid, and then talk about automated switching. So why did I choose this topic? Well, I currently work as an electric distribution engineer, and this topic interests me because it relates to my current project work. I want to take my existing knowledge in distribution engineering and explore how it can be used to create a smart power grid. So, a quick overview of the existing power grid. Generation is where energy is captured and converted into electricity. From there, we step up the voltage using a step-up transformer, and then it moves into transmission. Transmission is when we have very high voltage power lines that travel a long distance. Then once we get closer to the point of consumption, we then step down the voltage, and then the electricity travels through a distribution network. And then from there, the voltage gets stepped down again, and then it feeds each customer. There are different types of generation methods. We have coal-fired power plants, natural gas, hydroelectricity, and then wind and solar. So what are some of the technologies used in a smart grid? Well, one of them is a smart meter. This measures electric consumption. It sends real-time data back to the utility, and the energy usage history can be tracked during special events. The reason why this is important is because when you have special events, different events will use different levels of energy. And being able to track this, we can use this to predict the amount of electricity that will be used for events in the future. Digital twin technology can be used to simulate the performance of a power grid and test its performance and behavior. Artificial intelligence can also be used by the algorithms can be used to forecast demand patterns and predict equipment failures. So now I'm going to go over a specific use case. So in figure one, this is what an existing power grid typically looks like in a neighborhood. You have four transformers, that's the yellow box, and each one feeds a neighborhood. Notice the direction of the power in which it's flowing. Each color is a different circuit, and currently each neighborhood is being fed from the same circuit. Well, what happens if, say, a car were to hit pole A? Well, when that happens, it takes out the majority of the power of these homes. Notice how neighborhood 1, 3, and 4 is now grayed out and they all lost power. Using the outage data from the smart meters and the geometry of the grid layout, we can determine the potential poles can be identified. When we combine both the IoT-based traffic cameras as well as object tracking, we can get a good idea of the exact pole that was hit by that car. So once we know the exact pole that was hit, the switch at pole C can automatically close and it backfeeds the homes and the neighborhoods that previously lost power. So now the green circuit is now feeding neighborhood 1, 3, and 4. So in conclusion, by combining smart meters, digital twins, object tracking cameras, and automated switching, the grid can become more reliable and power outages can be reduced.